Okay, let's go over the sample test. And I want to give you a heads up. The sample test that I handed out in class doesn't have one problem that I'm putting on this sample test. And that's problem number, I'm adding a problem, problem 6 before that last page. All right, to do number 1, the first thing we want to do is to graph this. So I'm going to pull out my graphing calculator and I'm going to type this thing in. I do it on Desmos, except that if I do it on Desmos, then I have to point the camera at the screen and it's a little harder to do. So I'm going to go to y equals clear and type in, what does it see? 3x to the 7 minus 22x to the 6. Whoop, forgot to push something. 7 over minus 22x to the 6 over plus 44x to the 5th over minus 56x to the 4th over plus 128x to the 3rd over plus 128x squared. And I'm going to do zoom 6 and see if I can see the x-intercepts. Okay. I see one over here. Doesn't look like it's hitting a point very nice. Looks like it hit 0 twice. I'm going to right now assume it hits 0. In fact, I can look at the original equation. If it goes through 0, that means there's an x in all of them. And it looks like there's an x in each term. And in fact, there's an x squared in each term, and that's why it bounces at 0. So that means it's a multiplicity 2. And so right away, I know that x squared factors out and leaves me with 3x to the 5th minus 22x to the 4th minus 44, almost missed a term, plus 44, x to the 3rd minus 56x squared plus 128x plus 128. Okay. So I'm looking for the easy ones. That was easy. It doesn't look like it hits 1 exactly. But it looks like it goes through a half up here. I'm going to go to second, calculate the 0. That's up here between like 1, 2, 3, 4, and 6. So I'm looking between 4, enter, 6, enter. Yeah, I got the marks here that say between 4 and 6. And it's around 5. And it says it's at 5.49. Ooh, that's not perfect. 5.5. It's close to 5.5. Let's go to second, calculate the value at 5.5. One, two, three, 4, 5.5. It's not 0. Did I type something wrong in here? Because that doesn't. 3x to the 7th minus 22x to, oh, that's, no, that's right. 22x to the 6th plus 44x to the 5th minus 56x to the 4th plus 1. Oh, it's supposed to be plus 128. And there's the problem. And this is something you guys got to watch out for. Plus 128x to the 3rd plus 128x squared. All right, if you don't type it in right, you're going to get issues. This still has an x squared and everything, so if I push graph, it should still bounce at 0. hopefully now I got nicer numbers. I only saw 3 of them. There's supposed to be 7. Some of them would be imaginary, but not all of them. So 3x to the 7 minus 22x to the 6 plus 44x to the 5th minus 56x to the 4th plus 128x to the 3rd plus 128x squared. Okay, graph. Let's go zoom 4. Oh, there's one over there. Another bounce that didn't show up in the other graph. And that's at 1, 2, 3, 4. Let's check that. Second, calculate the value at 4. And it says it's 0. So there's 4. It bounced, and so it's a double. Sometimes they don't show up. You have to do it carefully. Desmos is a little bit better on that. And I have one over here that's, let's see if we can figure out that one. That's between -1 and 0. Second, calculate the 0 between -1, enter, and 0, enter. And my guess is going to be -0.5. And it says it's -2/3. Because I know 0.66666 repeating is -2/3. And that happens once because it went straight through. So now I'm up to 2, 4, 5 of the 7. Good. If I'm up to 2 left, then I can get it down to a quadratic that'll have the other 2. And they're probably imaginary because I don't see any other places where it's hitting the graph. All right. So to find the other 2, we can divide by long division, but so far I know it's an x squared, and there's a 3, so I have a coefficient of 3, an x squared, an x minus 4 squared, and an x plus 2/3 to the 1. And there's some more, and I've got to try to figure that out. Well, if I take the x squareds out, I get this stuff. And I'm going to do synthetic division, write these coefficients down. I have 3x to the 5ths minus 22x to the 4ths plus 44x to the 3rds minus 56x squareds plus 128x plus 128. If I were ever missing a power in the decreasing here, like if there were no x to the 3rds, I'd have to put a 0 for the x to the 3rds. I got to have every power of x going down. If there's any missing, I have to put zeros in for them, placeholders. Synthetic division, all right. So we already took care of the zeros by factoring out the x squared. So now I'm going to try the 4. So synthetic division, 3 plus nothing is 3 times 4 is 12. Add, and I get minus 10 times 4, that's negative 40. Add, I get 4 times 4 is 16. Add, I get negative 40 times 4 is 100, negative 160. Add, and I get 32 negative times 4 is negative 128. Add, and I get 0 for my remainder. So it went in evenly. And that's good because it looked like it went in evenly. And it looks like it goes in twice. So now I'm going to do 4 into what was left. Forget the remainder, so I'm only working to here. 3 plus nothing is 3 times 4 is 12. Add, I get 2 times 4 is 8. Add, I get 12. 4 times 12 is 48. Add, I get 8. 4 times 8 is 32. And I get 0. It went in evenly. And that's what I need to have happen. Now I've taken care of 2 4s, 2 zeros by pulling out the x squared, 2 4s here, that's these two, and negative 2/3. So 3 plus nothing is 3, times negative 2/3 is negative 2. Add these, I get 0. Negative 2/3 times 0 is 0. Add, I get 12. Negative 2/3 of 12 is negative 8. Add, I get 0. Went in evenly. So now I have this. Now this was, I've taken the x squared out, so it was x to the 7th, then it turned to x to the 5th. This was x to the 5th. This is x to the 4th, x to the 3rd. So this is 3x squared plus 0x's plus 12, which I can put into the quadratic formula where b is 0, a is 3, and c is 12. But since the middle term is 0, this is pretty easy to solve. I can say 3x squared plus 12 equals 0. Subtract 12. Divide by 3. Take the square root, and I get x equals plus or minus, see, the square root of negative is I, the square root of 4 is 2. So my other two zeros, oops, sorry, I went off the page there. Subtract 12, divide by 3, square root, the square root of negative is I, and when I do square root, it's plus or minus. Square root of 4 is 2. So my other two zeros are 2i and negative 2i. And so they happen each once and they're imaginary. So the rest of my factors are x minus 2i. Remember, if it's 4, we subtract it. If it's minus, we add it. So if it's 2i, we go minus 2i. And if it's minus 2i, we go x minus a minus, which is x plus 2i. And that is the complete factorization. So I completed the table. I factored this. This is b. Now I just got to go through and answer these other questions. What's the y-intercept? Well, if I put 0 in for all the x's, I get 0. So 0 for the x's gives me 0. That's where it crosses the y-axis. You can look at the graph again if you want. It crosses at 0. Crosses the y. Give the coordinates of the x-intercepts. Well, they are, when y is 0, x is 0. X is 4, we get 0. X is negative 2/3, and we'll get 0. X is 2i, we get 0. But that doesn't hit the x-axis, so those are not x-intercepts because they don't hit the x-axis. They're imaginary intercepts. Determine the end behavior. This is the 7th degree, and it's positive. A positive, the 7th would start from down there, come up and wiggle, and then go up. So it's down on this end and up on that end. Determine local maximums, if any. Well, if it starts down there, it goes up and hits a max, goes down, goes up and hits a max, comes down, and then goes on up. So there's a max somewhere between negative 2/3 and 0. So I'm going to go second, calculate the maximum. That's between negative 1 and 0, and I'm going to guess at negative 0.5. I don't have to be exact, just close. And there's at negative 4.65, the maximum is 10.99. So I got a local maximum of 10.99, and I might need where later. I don't need it for this problem, but I'm just going to say at x equal, let's see, that's negative 0.46. Now there's another max between 1 and 4 because it goes up and comes down and then it goes up. So I'm going to go second, calculate the maximum. That's somewhere between 0 and 4. And I'm going to guess 2. And it says 2.685 is where it happens at x equal 2.865-ish. But the maximum is 1,405-ish. 1045.07 says my calculator. Those are the maximums. This is the x value where they happen at. Local minimums. Well, it went up, max, down to a minimum of 0 and a minimum of 0. So the two local minimums are both the same. Local minimum 0, and they happen at x equal 0 and at x equal 4. I don't need this, and I don't need this for the answer. These are the answers. That's the answer. Now, where is it positive? Well, it's negative over here. It goes positive from that place to that place. It's 0 there, and then it's positive again to there. It's 0 there, then it's positive after that. So it's positive from negative 2/3 to infinity, except at 0 and 4. So when is f of x positive? From negative 2/3 to 0. It's 0 at negative 2/3. And then not including 0, but from 2/3 to 4, it's positive. And then 4 and on, it's positive. And when is it decreasing? Well, it's going up till it gets to this first local maximum, which happened at, and this is where I need it, at negative 4.6, negative 0.46. From there, that's when it reaches this top, and then it's coming back down. So it's coming down up till x becomes 0. So we do these in terms of the x's. The y values are getting smaller as we go from x negative 4.6 to x 0. Don't include these because it's changing at these places. And then it goes up until it gets to this other local maximum, then it comes back down. And that other local maximum was at 2.865. 2.865. And it was coming down until it got to 0 height at 4. So we'll stop at 4, and then after that it increases. That's page 1. That's the most complicated and time-consuming one. The rest of these should go a little faster. All right. A punter wants to have the ball go up in the air at time 0 when he kicks it and come down at 4.5. So, to get a polynomial that hits as at field height at 0 and at 4.5, it's going to have x as a factor to get 0 and a 0 at 4.5. So that's x minus 4.5. And gravity in the feet would be a negative 16. I'll put t because it probably should be t for time, and the height as a function of time. Maximum height, it would happen halfway between 0 and 4.5, which is 2.25. So if I go to my calculator and type in negative 16 x parenthesis x minus 4.5. I could use the calculate the maximum, but I'm not going to. I'm just going to calculate the value at, there's the graph going up and coming back down, at 2.25, half of 4.5. I could actually write in 4.5 divided by 2 to make sure I use the right number. 2.25, it's at a height of 81. Determine the maximum height, 81 feet. What's the average velocity between 2 seconds and 3 seconds? So I want to find out the height at 2. 2, enter, and it says it was at 80. And at 3 seconds, it's at 72, so it's on its way down. And so the change in the height, 72 feet minus 80 feet is minus 8 over the change in time, 3 minus 2, which is 1. So it's minus 8 feet. That height is in feet, and the time is in 1 second. Feet per second, minus 8 feet per second. Average velocity of the football just as the football leaves the punter's foot. So that would be at time 0, and at time just really close to that, I'll put in 0.1 seconds. So at 0, it's 0. And at 1, 0.1, I get 7.04. So in a tenth of a second, it's already 7.4 feet high. So the average velocity, I'll just use this as an estimate for it. 7.04 minus 0 is 7.04 divided by 0.1 minus 0, which is 0.1. And if I divide that out, I get 70.4. And this height is in feet, and the time is in seconds. So it's going 70.4 feet per second. Complete the square. So this is like y equals, factor out the 3 out of the first two. So I get x squared minus 4 thirds x plus something minus something, and leave the 10 out, hanging out there. So then 3, and then it's x minus half of that. Half of 4 thirds is 2 thirds, or 4/6. And then I'd have to square that, which is 2 times 2 is 4, 3 times 3 is 9. These 3 are in this, and so I get minus 4/9, still inside the parentheses, plus 10. So I get 3 times this, 3 times this, so the 3 would reduce the 9 to a 3, so minus 4 thirds plus 10. And this 10, this is 1 1/3 that I got to take away from 10. If I take 1 off, I get 9. Take a third off of that, I get 8 2 thirds. So the vertex, this thing is moved to the right 2 thirds. And up 8 2 thirds. So that's the vertex. It's right side up. And axis of symmetry goes, it's moved over to 2 thirds. X, it's always equation, x equals 2 thirds. Okay. Now we got to complete the square in this. Well, circles, if it's equal to 0, if it's equal to 0, not to y or x or some other function, you can just divide everything by the numbers front of the x or front of y. They should be the same if it's a circle, the front of the squareds. And so we're going to divide everything by 2. So I get x squared and minus 5x. And then I'm going to have to go plus something and minus something. And then I'm going to do the y's. So if I'm dividing that by 2, that's y squared. Divide the 8 by 2, that's plus 4y. And I'm going to do plus something minus something. And then there was this 2 already here that I'm going to leave off to the side. So it's going to be x minus half of 5 is 5 halves. That squared would create a 25/4 right here. So we got to get rid of that. This squared makes these, and we don't want that, so we get rid of it. This would be y half of 4 is 2, y plus 2 squared. But this multiplied out would create a 4 here. 2 times 2 is 4. So I'd have to subtract the 4. These are here. So what do I have left? Let's see. Negative 25/4 is negative 6 1/4. Minus 4 is negative 10 1/4. Plus 2 is negative 8 1/4. So I'd add 8 1/4 to both sides to get rid of this, this, and this. So it equals 8 1/4. And now we're in the form of the general circle, x minus however far it's moved sideways in the x, plus y minus how far is it moved in the y direction equals r squared. So the radius squared is this, so the radius is the square root of 8 1/4, 8.25, and that's good enough to leave it like that. And the center, the circle, was moved plus 2 1/2, 5 halves, and minus 2 in the y. So there's the center, and that's the radius. Next page. So, using long division, divide this into there. So I got 4x to the 5th minus 3x cubed plus 23x squared minus 6 divided by 3x squared minus 5. 3 times what makes 4? 3 times 4/3. When I multiply by 3, the 3's cancel and I get 4. And x squared times x to the 3rd makes x to the 5th. So it's 4/3 x to the 3rd. Take this times 3x squared, I get 4x to the 5th. Take this times 5, and I get minus 20/3 x to the 3rd. I'm going to draw the line, change the signs. Now I got to add all the like terms. These are like terms and they cancel out, so I get no x to the 5ths. See, 20/3 is 6 2/3 minus 3, so that's 3 2/3, or 11/3. Just a note to myself. 6 2/3 minus 3 is 3 2/3. X to the 3rd plus 23x squared minus 6. What do I take 3 times to get 11/3? Well, that would have to be a plus 11 ninths, because 3 times this would cancel one of the 3's and leave me 11 thirds. And x squared times another x will make x to the third. So if I multiply this times this, I get 3 2/3 x cubed. I take 5 times this and I get minus 55 over 9x. Now I'm supposed to subtract, so I draw the line and change signs. These add to be 0. This is an x squared. These are not, so I'm going to get 23x squared plus 55 ninths x minus 6. X squared goes into there. Let's see. That would be 23 thirds. If I take 3 times that, the 3's cancel and I get the 23. And I don't need any x's, so 23 times that is 23x squared. 23 thirds times 5 is 2 times 5 is 10 from 115, I believe, minus 115. And there's no x's, so that's it. Draw the lines, change the signs, add like terms. These are gone. That's got an x, so it's 55 ninths x. And then I got 115 minus 6, which is 109. This power degree is smaller than this, so that's my remainder that I write, plus 55 ninths x plus 109 divided by what I was dividing by. So there's my answer. That was messy. Synthetic division. Okay. I got 4x to the fifths, no x to the fourths, minus 4x to the third, no x squareds, 20x, x's to the 1, and 1x to the 0. What makes this be 0 is, let's see, 2x minus 3 equals 0. Add 3. Divide by 2. 3 halves or 1.5. I'm going to use 3 halves. So 4 plus nothing, 4. 3 halves of 4. That is going to be 12 divided by 2, 6. 0 plus 6 is 6. Times 3 halves. Half of 6 is 3 times 3 is 9. Add, I get 5. 15 halves. Add, I get 15 halves. Times 3 halves is 3 times 50, 45 fourths, which is 11 and a fourth plus 20. But that's 80 fourths, and 45 fourths is 125 fourths, times 3 halves is 125, 3 times 125, 375 over 8 plus 1, which would be 8 eighths more. And the 8 eighths more would be 370, 383 eighths. Didn't go in evenly, so I got a remainder. This was x to the fifth, so I got, goes down 1, so it's 4x to the fourth plus 6x x to the third plus 5x squared plus 7.5 or 15 halves x plus 125 plus my remainder of 383 over 8. My remainder over my divisor, which was x minus 3/2. And all of this, since I used 3/2, and this has a 2 in it, it's x minus 3/2 times a 2. So I also need I divided by this. I need to divide this all by 2. That was a messy one too. Neither one of those will be that messy on the other test, on the real test. All right, parent function is y equals x squared. Key points 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4. If the y-axis is right there. Show units. Units. Okay. I'll start on the inside. Order of operations say multiply by 2 and then subtract to 3, but we do things backwards. Subtract to 3 actually moves it to the right 3. So 1, 2, 3, and if I go over 1, up 1, over 2, up 4, back 1, up 1, back 2, up 4. This should look like it's moved right 3. Units. Right's good enough for horizontal. And then, continuing on the inside, times 2, which you think it would make it twice as wide, but it makes it half as far from the y-axis. And that's where people will mess up. This is 3 away, so it goes to 1.5. This is 2 away, so it goes to 1. This is 1, 2, 3, 4 away, so it goes to 2 from the y-axis. This is 1 away, so it goes to 1/2. This is 5, so it goes to 1, 2.5. And the units. And this is a horizontal compression by a factor of 2. Half as much, or whatever you want to call it. And finally, we have a -1, so I just got to move this graph down 1 unit. So I'll put it basically the same way sideways. This one goes down to here, this one's here, this one's here, and 1, 2, 3, 4, this one's there, and this one is there. This is 2, and this is 2, and it's down, so that has to be vertical, 1. So where did -1, 1 go? It went to 2, 1, 1, 1, and 1, 0. That's the answer to that question. Final page. Degree 4. Well, my zeros, there's 1 at 2, so it has to be x minus 2. There's 1 at -2, so it's got to be x plus 2. There's 1 at -1 plus 5i, so it's x minus that, which would be +1 minus 5i. And complex always come with a conjugate. The square root in the quadratic formula, it's minus b plus or minus, so this part is plus or minus. So the other one has to be -1 minus 5i. So the factor is x minus this, which is +1 plus 5i. And then I could put any multiplier there if I want, but I'll just go with just that. And there's a fourth degree polynomial. 1, 2, 3, 4. This one, it crosses at -4. It actually bounces at -4. 1, 2, 3, 4. Bounces here. It goes through 2, because 2 would make it 0, and it goes straight through. And it goes through -1. And the leading coefficient, it's x times x times -x times x. So it's a -1. And this is 1, 2, 3, fourth degree. So fourth degree starts up and ends up, but since it's got a negative, it's going to start down, bounce, straight through, and down. So when is this graph's y values 0 or more? Well, 0 at -4. And it's 0 at -1. And it's positive, greater than 0, all the way to 2 and 0. And then it's 0 at 2. And then after that, it's all negative again. So that's the answer to that one. And finally, this one has an x-intercept at -3, 1. So it's x plus 3. Goes through 0, so it's got an x. It bounces at 2, so it's got x minus 2 twice. And it goes through 4, so it's got x minus 4. And there's probably a multiplier. And that's what the function's going to look like, except we got to figure out what a is. And let's see, do we have a nice point someplace? Looks like it goes through 1 minus 1, so we'll get pretty close with that. So I'm using 1 minus, minus 5, 4, 3, 2, minus 1. 1 minus 1. So I'm going to put 1 in for all my x's. So I got a times 1 times 4 times 1 minus 2 is minus 1 squared is 1. And 1 minus 4 is -3. And I'm supposed to get minus 1. So 1 times 4 times 1 times minus 3 is -12. So if I divide by -12, I get a is positive 1/12. So 1/12 there. And there's my equation.